In this example, we have a 4 kilogram block of wood on a rough horizontal table, and the coefficient of friction between the block and the table is 3/4. It is attached by two separate strings. So that's the first example with two strings. So here's two strings. I'm going to call them T1 and T2, two different strings. And they pass over smooth pulleys to hanging blocks of masses 3 and 10 as shown. Find the common acceleration in terms of G. Okay, when we look at the 3 kilogram block, what's going on with it? We have 3G going down. We have tension T1 going back up, and it's going to move or accelerate in this direction as 10 is going to move down in this direction. So that's my A. So I start with my T1. So my equation is T1 minus 3G. They're the resolved forces. That's equal to MA. So 3 times A. If we look at the 4 kilogram block, I'll just put 3 kJ here, 4 kilogram. The 4 kg block has the table involved. So I better draw the table here. Try and get a straight line for the table. So it's moving in this direction. So this is mu r going back in this direction. Mu r. We have reactionary force here. We have 4G going along here. We have two strings. We have T1. We have T2. And we can start this by saying R is equal to 4G because there's no other up and downs. And we know that friction mu r, when we get mu r, this friction here, mu r is equal to 3/4. This 3/4 by your 4G. So mu r is equal to 3G. And if we want our equation of motion, it's going to be going in this direction. So it's starting with T2. So what's going back? T1 is going backwards and mu r is going backwards. So T2 minus T1 minus mu r, which is 3G, that's equal to MA for A. So we have one equation. Be patient with these, you'll see what happens in a minute. There will be some cancellations. Equation 2. Then we have our 10 kilogram block, 10 kg. So we have 10G going down. The tension in the string is T2 and acceleration is going in this direction. So we start with our 10G, we take away our T2, and that has to be equal to MA, which is 10A. So we have a minus T2, we have a plus T2. We have a minus T1 and we have a plus T1. So when we bring these three equations together, you want to have probably done this in maths before, but we're going to add all three. So I'm going to line them up here. I have T1 minus 3G is equal to, so I'm going to write T1 underneath here, minus 3G is equal to 3A. And if I line the other one up, 10G minus T2, so minus T2 plus 10G is equal to 10A. You can see here that my tensions are going to cancel and I'm just going to be left with G and A. So I'm going to be left with minus 6 plus 10, 4G is equal to 17A. So the acceleration is 4G over 17, and that's the common acceleration in terms of G due to gravity, 4G over 17.